Hello and welcome to ECE 310. Today's topic is circuit analysis in the omega domain. First, we shall tackle what h of omega is, which is also known as the frequency response. Suppose we have an LTI, or a linear time invariant system, and your input is the Dirac delta function, and your output is h of t, or the impulse response. Then, if we have an input function x of t, and we put it through the same LTI system, we will get a function y of t, which is the convolution product between x of t and h of t. This can also be written in the omega domain as y of omega is equal to h of omega times x of omega due to the convolution property. Rearranging this equation, we get h of omega is equal to y of omega divided by x of omega. Now let's move on to impedance.
Suppose we have a component that has a voltage drop of V of t, and the current I of t passes through it. Then, to write this in the omega domain, we will have the Fourier transform of V of t divided by the Fourier transform of I of t, which equals to V of omega divided by I of omega, which equals the impedance Z of omega. The impedance Z comprises of two parts, the resistance R plus the reactance times the imaginary component J. The inverse of impedance is called the admittance, which comprises of two parts, the conductance and the susceptance times J. Let's convert our three primary components, resistors, capacitors, and inductors, into impedances. For a resistor, let's say VR of t is equal to IR of t times R. Then, in the omega domain, ZR of omega is equal to V of omega divided by I of omega, which is equal to R. Then, for an inductor, let's say VL of t is equal to the inductance times the derivative of the current IL of t due to time. Then, in the omega domain, ZL of omega is equal to J times omega times the inductance. Then, for a capacitor, let's say IC of t is equal to the capacitance times the derivative of VC of t due to time. Then, in the omega domain, ZC of omega is equal to 1 over J times omega times the capacitance.
Now let's do an example where we find the frequency response h of w. For problem 1, let's say we have the given circuit. Then, we convert the circuit into the omega domain. R stays as R, and the capacitor turns to 1 over JWC. Then, h of w is V out of w divided by V in of w, which is equal to 1 over JWC divided by R plus 1 over JWC, which is equal to 1 divided by RJWC plus 1. Thank you.